that's enough on VirtualBox. I think I'm going to be able to get most of the way through Dockerization, except probably for the very last example. So we will start off with Dockerization now. The difference between a virtual machine and a container is that a container is lightweight. You don't encapsulate the entire operating system. What you have is a lightweight standalone executable package of a piece of software that includes everything needed to run it: code, runtime, system tools, system library, settings. So what does this mean? Well, you start from an image that's a stripped down version of whatever you're trying to run. So for example, if you want to run Python, what you have is you have an environment with an environment that can run Python. It's probably going to look a lot like a Linux box, but the underlying important thing is that you have Python installed. And then you just install enough other stuff so that whatever you're trying to run can actually run. You don't install a whole operating system. You install some links to libraries, and you install some things that link back to your virtualization layer, which is now at the application level instead of at the hardware level. The application level interacts with your container level. No guest OS. The guest layer's capabilities come in as shared services in the Docker layer. So you have this Docker layer, container layer that is down there providing services. You can make calls into it. Everybody shares the same kernel, and each container runs as an application in the user space. So you are protected. Your protections aren't quite as ironclad as they are with a virtual machine, but they are kind of running separately, and the container itself provides a bit of security as well. Containers are generally stateless, so every time you start a container, you start from the same state. If you want to advance state, what you have to do is you use existing system resources. So for example, if I want to have a checkpoint file, the checkpoint file would be on my actual disk drive, and I would map that disk drive into my container and write to it using the same system calls, essentially buffered through this container layer. The reason containers came about were all the problems that I have with VMs. VMs are huge. They have high latency and they have reduced performance, right? So, that's pretty much inescapable. By linking directly to the host kernel, containers can have a reduced size. They don't need to provide all of the data. You're not emulating the hardware, so they don't have to have the stuff necessary to interact with the emulated hardware. All they have to do is they have to translate calls from your code into operating system calls that already exist to access the hardware or the resources on the host system. They can share resources, and because they've stripped out a lot, and they've stripped out this entire operating system layer that doesn't need to exist anymore, they can have greatly improved performance. Disadvantage is, well, you're building them from the bottom up, only adding those things in that you actually need to run your application. So while they're very compact and lightweight, at least compared to an equivalent VM, you do need to install and configure everything you want to use in your container. Right now, there are some cheats. You can start from, if you want to do Python, you don't have to start from a bare bones bash shell. You can start from a Python image. If you want to do Node, you can start from a Node image. That gives you a step up. It installs some of the basic stuff. But after that, you are essentially going through and installing everything you want to have working on this in this container. The architecture is a little different, right? So if you look at the VM architecture over here, right, this is our virtual machine. We have our application communicating with libraries specific to that virtual machine, communicating to a guest OS that communicates to a virtualization of the hardware that then communicates to the actual hardware. So this is what a virtual machine looks like. This is what the container app looks like. So you have the infrastructure, you have the host OS, right? Now you'll notice that this hypervisor has to be running on top of the host OS, or the host OS is somewhere down in there's your machine is running some kind of operating system, but the communication is through the hypervisor. This Docker layer replaces all of the guest OSs. And then these bins and libraries make calls through the Docker layer right into the host OS. So you've gotten rid of this entire guest OS layer. You're still using the host operating system, and you've thrown this Docker layer in between that can be much more efficient than the guest OS hypervisor kind of infrastructure. All right, so this is what a container looks like, looking specifically at Docker. Docker is let me bring up my Ubuntu, right? When you're running Docker, basically you have a Docker engine and you can communicate with it from the command line. So you can look at what images, what applications you have currently installed that you're ready to run. And I have a bunch of them that I ran when I was trying to get this figured out for you guys, make sure everything still worked. And by the way, not everything still worked. We had to fight through this one a little bit. WSL2 is a vast improvement on WSL, but it did complicate some things. When you want to run, you can do something pretty simple. So we can just do something like yeah, we'll keep both of these up for now. It's easier if I can actually just look at the slides as opposed to anyway. So let's say we want to run something. We could say Docker run. We'll give it the flags IT, which essentially puts it into interactive mode. And we will say we want to run the project Docker/whalesay, which is a pretty standard test image. It comes up. We're now running. We're actually running a Docker container at this point. So I can do something like, is it whalesay or is it cowsay? So despite this being the whalesay image, the actual program is cowsay. And if you want, on your Linux installation or in your Ubuntu, you can install cowsay. It gives you something a little different than this. But basically, we're running a Docker container that has access to the cowsay program, a pretty simple one. And all it does is it lets you say things, and I will exit it. And do I have it installed? No. I'll just do this while we're waiting. All right, so I'm not going to do this one just yet because I don't actually have any containers running. So it's going to show us absolutely nothing. But you can always find out. I was running in an interactive mode, so we knew we were in a container. We had the container prompt up. But you can run your containers in the background. And when you do, you need to find out what containers you have running. So just like the PS command will give you what programs you have running in Linux, the Docker PS command will give you what containers you have running in Docker. It's really easy to create Docker files. So what you can do is you have, if you want to create a new image, your own specific project for Docker, in which you're going to encapsulate all of your development environment, let's say for one of your projects, you can do it just by creating a Docker file. And then, actually, we're not doing too badly today. By the way, here's what cowsay does. Cowsay has a cow that says it. And they've changed it because the image for Docker is a whale. They've changed it to be a whalesay with a whale image using ASCII art. You can make your cow or your whale say whatever you want it to say. So you create a Docker file. So if we come down here, I am in this app directory. You can see I have a Docker file. What is? I'm apparently missing out on a bunch of chat because I'm seeing things going back and forth. There may be questions, but I was in the wrong window. Oh, if you pipe it into lolcat, you can get a rainbow cow too. And yeah, you guys know more about you guys know more about cowsay than I do apparently. And I've never tried lolcat. I will do that. All right. So you have this little Docker file, and just like we have a make file that tells us how to make something, our Docker file tells us how to provision a Docker image. Right. This is a pretty simple one. It's for an example that we have actually in our notes. It's actually the Docker example from the Docker website. The question is, do we have enough time to go through this, or should we wait? Yeah, let's see where we get to. I can always go through it again on Friday. So if you're running a pre-canned image, and there are a lot of pre-canned images, you can do it with just Docker run, and then you specify, where the image is from, like Docker/whalesay, right? This says in the Docker repository under the account Docker, find the image whalesay and run it. And of course, I didn't put this in interactive mode, so it'll just run and end. And I don't think it's actually still running because all that does is run until you until you're done, and then it exits. So so this is a canned, essentially repository, Docker container stored out in the Docker Hub, You can build one yourself by building this Docker file. So let's walk through this for a second. We'll walk through at least as much of the examples as I actually can before we end. Right, and you can see that this Docker file is just 6 lines. All right, so let's go to this example. This is the last thing we have to do today. So I kind of feel, by the way, there is a cheat sheet here. This is a list of pretty useful Docker commands. If you want to list, Docker containers running all in quiet mode, etc., the Docker ls will help you there. Right, so I have no running containers. I do have some containers, right? I do have, that just gives you the identifiers for the same containers that all gives you. So AQ is all quiet, so it gives you minimal information, but it does give you all of your containers that you have. And you can see that I was running whalesay about a minute ago, which is and I was running an earlier version of whalesay about 6 minutes ago. So, all of those are available. That's the run command we're using. This is listing Docker images. We showed that already. Just some information on Docker. And then when you mess up and you need all the commands, you can get those as well. We want to go through the first 4 exercises in this Docker tutorial. So part 1 through 4 is all we're going to go through for the rest of this class or the beginning of next class. What I do want to show you, however, is if you are using WSL, this is the stuff I had to add. It took me a lot of poking around to get this right, but Docker will work with WSL too. The last time I ran this, it essentially wouldn't. I strongly recommended against using WSL2 or WSL. This time I am actually using this under WSL. I bit the bullet just so you guys who are running on it would have the advantage of me having piloted the ground once. You do have to install WSL. You have to update to WSL2, and then you have to go through and enable some things on your Docker window. So follow those, do your normal installation and follow the rest of these directions, and you should have a working WSL2 installation with Docker. And what that gives you, other than and then, of course, if you don't want to go through that, I will pop this into the chat. There's also Podman. This was recommended to me by Steve Van Zyl, who's one of your mentors. And he says that this is easier and doesn't require a Docker server to be running on your Windows system. Unfortunately, I didn't get that until after I had already done these other notes, and I didn't have time to go back and see it. So if you want, you can check that out as well. That may be easier than the 2 steps that I already gave you, and we will, I'll add that into the lab instructions at some point this week. So anyway, those are at least 1.5 ways of getting Docker installed under WSL. Okay, so we're going to go to this tutorial. The tutorial is, do I have the tutorial yet? No. Okay. So the first thing the tutorial tells you to do is to install Docker. So follow the instructions for Windows. It will probably have you go to the places that I told you needed to go to, but make sure you have those links available so you can get this all installed correctly if you are using WSL2. The other 2, by the way, Mac and Linux, work probably better. They certainly don't work any worse. What we're going to do first is we're just going to run, we already ran Whalesay. We're going to run a quick little getting started container. So we can come in here and we can do a Docker run. This time we're going to do it a -D, which means detached. So instead of having an interactive Docker window that we can interact with, this is going to run in the background. We have this little P thing here. I'm going to tell you that this sets up a website. The P says map port 80 into port 80. So port 80 is defined in this little website we're going to set up. And we're going to map it to port 80 on our current machine. And when we do that, it's going to go out. It would go, so it's going to go out to Docker. It's going to download the latest getting started guide, and it's going to, once it's done that, it's going to actually run it. So now if we do a Docker PS, what we will see is we actually have this getting started guide running for 22 seconds, and it maps a TCP port on localhost 0.0.0.0 port 80 to the port 80 TCP, port 80 on the TCP client. So if we now go to localhost and port 80, what we'll see is that we have a little Docker tutorial here. And actually, this is exactly the same tutorial with some numbering things that are a little bit different that we're actually running through on the main Docker site. So the other thing we want to kind of bring up is they have this Docker desktop. I tend to do everything from, or as much as possible, from the command line. Everybody else seems to not like command lines. I don't know why. So they created this little Docker desktop that we can use that will eventually pop up. Maybe, if we're lucky. I am not seeing it pop up. Let me try one more time. Oh, there it is. Never mind. Just slow. I've got too much running on my thing now. There we go. And you can see that this is the container that I have running, right? This is the Docker getting started. Here's the whale say that ran a little bit ago. Here's the whale say that we actually this is the one that we tried to spawn in the background. This is the one we actually ran with. And then there's some other versions of it that I ran in previous iterations of testing this out. So this is a nice little interface if you like nice little interfaces, and it allows you to do things like troubleshoot and configure, right, and do all sorts of other things that you can do just as easily from the command line in general. But if you like, instead of using Docker PS and Docker images and things, you can see them here as well. I'm going to kill this for now, and actually, I think I'm going to save steps 2 through 4 for the start of lab. We're in good shape right now as far as time goes, and there's no reason to hold you guys here any longer. So have a nice day. We will stop the lecture here, and we will start up during our lab on Friday. We'll take the first 5 minutes to go through the rest of this tutorial. What we'll do is we'll show you how to use a Docker file. We'll show you how to use a Docker file. We'll show you how to throw something up to your Docker Hub's repository, right? It's like a GitHub repository for code. This is a Docker repository for containers. We'll show you how to do that, and then we'll turn you loose on the lab, which will have you do a lot of that on your own and generate some really cool applications. All right. Thank you all. Any questions while we're exiting? And CalSay only says what you tell it to say, right? So I don't know. If you're only doing what CalSay says, that sounds a little suspicious to me. No, I haven't used SL before, Eli. I've used Fortune before. Oh, so you pipe Fortune into CalSay. I will do both of those. But if my machine totally dies, then I will blame you.